Okay, so this problem. Okay, even if you knew, I'm going to go ahead and review the first page. Okay, so this one says the graph shows the amount of ice cream remaining as a function of time. Answer parts A through D using the graph below. So if you can't read this, on the left-hand side it says ice cream remaining in gallons. So this part says ice cream remaining and then gallons. Okay. And this says time in minutes. Okay. So it asks us what is the independent variable, and I'm okay with you writing IV, that's totally fine, or dependent variable. So here, remember that the independent variable is being affected or is not being affected. It is affecting an outcome of something. And so usually, and I want to say actually always, the independent variable represents the x value. So the independent variable will always represent the x values, right? So in this case, what is representing the x values here? And you want to look at your graph to see what is the label for the x values. Right there. Minutes. So we have time in minutes. So the independent variable will be time in minutes. Okay. And then Daniel, did you have an idea for what the dependent variable is?
Ice cream gallons.
Right, so and here would be ice cream. I'm just going to say remaining because that's what they tell us, and then in gallons, yeah. So the reason we know that the dependent variable is, again, that it is the dependent variable is because it's located right here. So the dependent variable will be right here. The independent variable will be located right here. Okay. The reason that is because, again, the independent variable is not affected by what's going on. It just kind of happens, right? And it affects the dependent variable, or what we're measuring here. Okay, so B asks us what type of slope is being shown. So you can see here that as we're going from left to right, it's decreasing. So we know that the slope is negative. Okay, so it's a negative slope. Okay, so this part where it says what is the rate of change, this one seems a little more complex, and it's actually related to the other problems. So what you need to do is you need to select 2 points on the graph, and I'm going to go ahead and select 2 points which I think are the easiest to select. So when I have the y-intercept at 0, 6, and then I also have a point here which is right, it seems like in the middle at 4, 4. So what I can do is I can solve. I can go y2 minus y1 over x2 minus x1 is equal to the slope. And then I could do 4 minus 6. Again, I'm just taking I'm going to call this my x2, y2, and this is my x1, y1. I have, so 4 minus 6 and 4 minus 0 equals negative 2 over 4 equals negative 1/2. So my rate of change, or my slope, is equal to negative 1/2. So again, what I did is I chose 2 points on the graph. Then I went ahead and used my formula for my slope. I went and plugged them in, and I subtracted, divided them, and I got my rate of change, which is negative 1/2. One thing that you can keep in mind is, does this rate of change kind of look right? Does it look like it's decreasing, which means that my rate of change would be negative? And if it is, then it probably matches up, right? Question, Rick?
Wouldn't the faster method lead us to take those 2 points and count, like one up and then left 2?
You could also do that. You could say, okay, is it down 2 and then over 1, 2, 3, 4, and then you can get the slope 2. That's fine too. That's a very creative way too. So in here, what is it, when it asks us what does the rate of change mean in the context of this situation, right? So we know that, again, rate of change is equal to the change in y over the change in x. So this is telling us, and remember, y is telling us how much ice cream is remaining in gallons, right? How much ice cream is remaining in gallons. So this would tell us that as time is increasing, we are decreasing the amount of ice cream, right? The amount of ice cream remaining is decreasing as time is going on. And if you wanted to be more specific, you can say that you are actually losing a gallon of ice cream every 2 minutes. So again, the first one, the first number, the number on top, is telling us that, well, 1 gallon of ice cream is decreasing for every 2 minutes that passes by. Okay, so if you wanted to be more specific, the numbers are telling us that 1 gallon of ice cream is decreasing every 2 minutes. Okay, someone's either eating ice cream really fast or they're selling ice cream really fast, whatever the case. Right. So in this case, I would write the amount of ice cream is decreasing by 1 gallon every 2 minutes. Okay. So the amount of ice cream is decreasing by 1 gallon every 2 minutes, and I know this because 1 represents the change in y, and 2 represents the change in x, or time. Okay, so just like the last chapter, it asks us what the y-intercept is. The y-intercept is right here in the beginning. Okay. So the y-intercept is right there in the beginning. So let me go ahead and point that out. Y-intercept. So again, the y-intercept is where the graph itself, or the line, crosses with the axis of the y-axis. So here would be 0,6. In this case, it would be 0,6. And what that would represent is, it represents the starting amount of ice cream that we have, right? It would represent the starting amount of ice cream. And if you wanted to be more specific, you could say the starting amount of ice cream, you could say it starts at 6 gallons, right? If you wanted to be even more specific, you could say the amount of ice cream starts at 6 gallons. Okay? Okay, so in this case, you don't necessarily need to approximate. Sometimes they will not tell you the x-intercept. So this last question says, approximate the time when there is no ice cream remaining. So what that means is that when y is equal to 0, explain what happens. So we know that the x-intercept represents or stands for when there is no more ice cream. So we know that the x-intercept, or when y is equal to 0, stands for the same thing of when there is no more ice cream. Okay? So in that case, what we could do is, there are two things, is that if we didn't know the x-intercept, we could go ahead and solve for this. The other thing that we could do is we could just visually see that the x-intercept is right here. Okay? If you wanted to solve for it, again, what you would do is you would take your slope, and then you would plug it into your equation. So as an example, if we had this, we could plug in to our whoops, that is not the right one. Zero, 6. So you plug in the x-intercept because you want to figure out y is equal to 0. Oh, sorry. We do know our b. Sorry. Oops. Sorry, we do know our b. So what we could do is we can plug in our b, which is our y-intercept, and then we can plug in 0 for y. We could subtract from both sides. So here, to get rid of the -1/2, what we do on both sides is we multiply by -2 on both sides, and we get 12 is equal to x, or we get 12, 0 as our x-intercept. So if we were to answer this question, it would just be at 12 minutes. So after 12 minutes, there is no more ice cream. Okay. So again, if you're not sure what to do to solve for when the D question, you want to do what we did on the homework from the day before, where it's like one of these where it says contains the points 2, 5, or it says passes through -2, -7, 3, -1. You find the slope first, you plug in the slope, you solve for b, and then after you solve for b, then you solve for when y equals 0. Okay? Are there any questions on this? Are there any other questions? And again, I'm going to post this up, so if you want to rewatch this, then you can do so.